Yeah, good evening, everyone. Shanik, let's start off. Camps on, everyone. Let's start off with a problem. We have a mirror of length L. On the ground somewhere, we have a bulb. And this mirror here is going with a speed of V. At some height. No information is given. What height, what distance, and all. Now, what will happen? The light will go and fall on this mirror, and this will go and fall on the ground. Agreed? So we get a light spot. So the question is, find the length of the light spot and the speed of the light spot. Let's get this. Others, keep your cams on. I sent you some sheets yesterday. Make sure to go through them. It is actually in each sheet you have everything. Kinematics, LOM, friction, that is one part. Second part, you have circular motion, work per energy separately. And I also provided solutions for them also. If time doesn't permit, do any one of them. Doesn't matter which one you want to do. If you can do both, it will be great. So I would feel like, what the best thing for revision would be, do notes. Again, when I say do notes, take out the notes, do each and every problem again on your own. And second thing, finish off these two sheets. I think if you can do this much, and top of it, I'm going to conduct a test also. That वो जो हमारा regular online test है, that also will be online, same portion पे. I will try to keep the next week test also a little early only. So you'll have ample of practice for physics. So choose what you have to do. Don't get overwhelmed doing everything. Notes, those sheet. If time doesn't permit, do one sheet and write the exam I'm conducting online. I think that should be a good amount. You have to study other subjects also, no? Physics is not the only thing. Get this. I hope the question was clear. We have a bulb on the floor and there is a mirror at some height of length L going with speed V. The light from the bulb goes and hits the mirror and falls on the ground. You get a light spot. If the mirror is moving with V, find the length and the speed of the light spot. I just taught you one concept last class, reflection. Other than that, we are not doing anything new. We are just taking that and twisting it and playing with all different things. Meaning, I could ask you this question as a kinematics also. Any answers? The length will depend on the position of the mirror. It doesn't actually. It doesn't depend. I would have given if it depended. Think, I'll give a minute and then I'll show you. Who is missing? Length would be as function of L. If you think it will be a function of L, do that. Assume some length and then try to solve. Who is missing? Ali is missing. Ali, yeah. Let me help you. Remember this thing, whenever they ask you length of the light spot, whenever they ask you, up to what distance can you see the image, you always take the extremes. So this is the light bulb. So what I will do now, I will take a light ray here, and this will go and fall somewhere here. So let's call this point A. Let's call this point A dash. This angle and this angle will be same. This light ray, which will go and hit this corner, will go and fall somewhere here. Let's call this thing B dash, and this is B. Now let this distance be X, which is changing. Okay. Then this also will be X. And if you look at the green one, let's call this point O. So this would be L plus X. Then this also will be L plus X. That is because these two angles are equal. Making sense? Then this is your light spot here. So what is the length of the light spot? A dash B dash. Which is nothing but OB dash minus OA dash, which is 2 times L plus X minus 2X, which is 12. It is constant, independent of the distance, height, nothing. It doesn't matter. It is always 12. Kuch bhi karo, it is always 12. Just don't rotate the mirror. You can move it front, back. You can go up, down. Doesn't matter. The length is 12. And what about the velocity? If you look at VA, that will be dx by dt, which is V. If you want the speed of A dash, that will be d 2x dt, because OA dash is a length. That will be 2v. So therefore, speed of the light is also double. Meaning, think about it. Every time you go forward, this will change by x, but A dash will change by 2x. That means the A dash is changing 2 times faster than A. Please check. Easy one. This could be a kinematics question also. Yeah, with little reflection though.
Sir, could you explain the velocity part once?
Udyan.
Sir, I didn't understand the velocity part, VA dash.
What is A dash ka coordinate? 2x comma 0, na?
Yes, sir.
What is VA dash? Rate of change of OA dash, which is d by dt of 2x, which is 2 times dx by dt,
Okay, sir. Okay. Understood.
which is 2v. VA क्या होगा? Rate of change of OA. That will be dx by dt, and that is given as v. You could have done the same thing with b also. You would have got the same one. Easy, everyone? Clear? Please check. Anyone not convinced with this, please ask. It's a good one. Next one. Mehan, Neil, clear with this? Venkatesh, Vartika, Anusha, got this? Rehan, clear? Palaksh, Niranjan, got this? Great. Next one. Say. We have a spherical mirror. Radius r. From here, from the center, there is a bulb here. Power of the bulb is P. And this is at a distance of r. From here to the center will be 2r. This radius will be r. Now, these light rays will go and hit the mirror and reflect. Na? Light rays will, some will bounce, some will go off like this. So the question is, find the power reflected by the mirror. The total power is P. How much power is getting reflected from the mirror? Find power reflected by the mirror. Let's see how will you do this. Meaning this light ray will go like this will go like this will go like this. Some will not touch only, some will go like this. Some will go like this, ऐसा. So the question is, how much power is getting reflected from the mirror? If the total power P is going in all directions, how much power is reflected from the mirror? Question is clear? Try. This is more calculus based, but we don't need to use calculus actually, if you remember the result. Think for a minute, then I'll give you a hint and then I'll show you. How do we do this? P by 6. Interesting. How did you get that? Nah, it's not P by 6. It's not answer nahi aayega. I know what you guys did. You just found the angle and you divided by the ratio of angle. Tell me one thing, is the power will go in a 2D or 3D? Power will go in 3D. It will go in the form of a cone. You can't use linear angles. You can't say it will go in the ratio of these angles. You guys are taking plane angles ka ratio. Now, in case you forgot, there is a. Do you guys remember this result? If you have a sphere, a part of the sphere, shaded area, anyone remembers this result? Anyone? 2 pi r square 1 minus cos theta. Told you to keep this in mind. This is the third time you're seeing this. First time you saw it in calculus, where I told you quite an important result. 2 pi r square 1 minus cos theta. The second time you saw this in friction. Dust is sprinkled on a sphere, find the area covered in dust. This is the third time you're seeing optics. Again, you will see this thing in electromagnetism. Again, you'll see this in modern physics. You will see this again in this chapter only once more. So how do you use this thing? See. So this was the sphere. This was the bulb. So the light rays which become tangent, these are the last light rays, right? After that, there's no reflection. So these are the final rays which become tangent basically. And remember, this is just not two light rays, okay? There is actually a complete cone kind of thing. It's like this, isn't it? All light rays between this region will get reflected. All light rays in this region get reflected. How much is that angle? So if you take this thing as the bulb is B, this is O, this is A, O, A, O, B, A. This is R, this is 2R, this is 30 degree. That meaning this is 30 and this is 30. And then what you guys did, some of you took that thing as 60 degrees, 360 ke liye power P and 60 ke liye you took P by 6. But it is a 3D thing. So how to do from here? Now see, look at the logic here. If it was a full sphere and if the bulb was in the center, for an area of 4 pi r square surface area, the power would have been P. Agreed? The power is going in 3D, right? But you're looking at this area now. You're looking at an area of 60 degrees ka area you want. That is 30 degrees here. So what is this area here? 2 pi r square 1 minus cos theta. Ke liye power is how much? Is that making sense? Because light rays, right, are going in all directions, but only these light rays are get bouncing off. This would be a power reflected. Meaning you can think of like this here, basically, like, this was part of a sphere aisa. Making sense? In that, the 60 degrees ka thing was going off. So you should not take linear function, huh? You should take it as angles. Power reflected would be unitary method, 2 pi r square 1 minus cos theta by 4 pi r square p by 2 1 minus cos theta. Theta is 30 degrees. Check it out. So all the light rays within a region of 60 degrees will bounce off. And for 60 degrees or this 30 degrees ka half angle, the surface area will be this much. So basically we're talking about this disk here. All the light rays in this disk will get reflected. Clear with this? This is a blunder if you do like this. If you say 360 degrees के लिए power is P, 60 degrees के लिए power is P by 6, this is wrong. Because power is going in 3D, it is not going in a plane. Keep that in mind. It's a good one. Like I said, it's more of a calculus problem than actual this thing. We are just using in that part reflection करके to get the angle. Check it out. Ali, clear so far? Be on time, Ray God. You know there is a class. Why do I need to give you a reminder that you have to come to the class? Any doubts on this? Yasha, Swastika, got this? Clear, no? Aditya, got this? Adrit, Abhinav, Venkatesh?
Yes.
Clear. Udayan, Ronak, clear. Anyone not convinced with this? Maulika? Sure, right? It's a good one. That result is important, huh? Don't forget that. By heart that. आएगा वापस और 3 बार आएगा at least. Next one. What's an object and what's an image? Point object and point image. Would the theta be 60? Meaning ये पूरा angle 60 है ना? This is sine theta is 1 by 2, right? Half, na? Half angle is 30, Anusha. Full angle is 60. Is that what you're asking? And this formula is derived for half angle only. This 2 pi r square 1 minus cos theta, this theta is half angle. Sure, still confused. The angle subtended at the center. This would be 60. But where is the bulb? Bulb is here, na? We need this angle, isn't it? Makes sense. Bulb is not at the center of the circle. So here what we are doing is actually we are assuming as if this had been a circle, the total power would have been P. How much power is passing in this region? Understood? That way. Be careful. This is a bulb. So what's a point object and a point this thing? Again, there's some definitions here. So what is a point object? A point from where light rays emerge. It's called a real object. Or appear to emerge. It's called a virtual object. I'll give you examples. Everyone is finding the screen fine, right? Or you finding it screen too small, something like that? Nothing. Yesterday, your seniors were complaining. I did something and they're like, the screen is too small. Okay. They're used to it now. I changed my tab actually, so I got a bigger screen. My previous tab was 10-inch. I brought Samsung Ultra 14.1-inch ka tab. Kada bhagwan. So this is a virtual object. Then what's the point image? A point where light rays converge. If the point light rays actually converge, it's called a real image. Or appear to converge. Is a virtual image. This idea, right, is important. Now, how do you find the location of an image? I'll give you an example, things will get more clear. Assume two rays from the object. After reflection or refraction, the point where they meet or appear to meet is the image. Appear to meet when extended. Let me show you what does it mean. But got the meaning of definition once. Let me show an example and then I'll get back here and then let's see if you're still confused. I'll explain you again. Let's say we have a lens. Now listen carefully. This is where the actual thing starts. Like I said, the most important thing is the sign convention and the formulas. So before convention, this is the idea there. So lens and we have a mirror. Let's say we have an object here. The light rays, let's say, will go through the lens. They will meet somewhere here. This is your I1. Then light rays go from here. They bounce off this mirror. And when you extend them, it feels as if the light rays are coming from here, I2. Now, when the light rays are coming out again, now it feels the light rays are coming from I2. They'll again pass through the lens. Again, they will meet somewhere here at I3. You're getting it? We will be seeing these kind of questions. So you have to do the problem till light ray finally goes off to infinity without coming back. So in this scenario, the light rays are passing through lens, mirror, then again lens. So if this question was given later on, we have to solve it 3 times. Now look at this thing. First, if you ask the lens, who is your object? The lens will say, okay, my object is O, light rays are coming from there, and this guy is real because light rays are actually coming from there. And he will say, my image is I1, and this is also real because light rays are actually meeting there. You're getting the meaning of it? The point where the light rays emerge is a real object. The point where the light rays meet is the real image. Then, if you ask the mirror, okay, who is your object? Now see, depending on who is your object and who is your observer, object and image can change. The mirror will say, okay, my I1 is my object, and that guy is real because writers are actually coming from there. And sorry, real. I2 is my image, right? Light rays appear to meet there, but they don't. It's actually virtual. So when you extend them, they should appear to meet at least. Now, again, when the light rays go back, they're again going through the lens. If you ask the lens again, boss, who is your image object? The lens will say, I2 is my object, which is virtual, because actually there is no object there. It appears light rays are coming from there. And who is my image? I3, which is real. So this whole concept of who is the object, who is the image will depend on whom are you observing from. So if I ask you, is I1 an object or an image? What should you ask me? Sir, who is looking at it, lens or mirror? The lens will say I1 is an image, mirror will say I1 is an object. I hope everyone is getting the meaning of, first of all, what is an image and what is an object. Object doesn't mean it should be real. You're getting it? The image of one system can be an object for second system and so on. So the whole concept of object and image depends on the observer. Just like, relative motion and all, it depends on the observer. So there's nothing like this is an image and this is an object. I'll just say depends on observer. Please have a look at this. This is very important idea. If you so like I said, ray optics may the convention and everything. This is the main crux of the whole ray optics. So if I give you 10 lenses and 10 mirrors, it doesn't matter. I will solve the problem for each lens separately, each mirror separately. So first lens ka image will be the object for second lens ka image will be object for third lens, and so on. I'll just keep solving the problem for each system. So calculations can be done for each system independent of another. Anyone not convinced with any particular part here, please ask. All understood? Can I go ahead? No. Previous page here. Loss of energy, yeah, there'll be loss of energy. Don't worry about that. You're not doing work for energy in ray optics. But yeah, some part does actually lose. The image will become, less bright. It will become dimmer and dimmer. More reflections and more refractions happen, image becomes dimmer. Clear?
Yes.
Anusha, clear, no? Next, image in a plane mirror. So if you have a plane mirror, if you keep an object, and when you extend the light rays, you get I here. This is standard stuff. I'm sure you studied in school. So if you call this OM, so OM will be equal to MI. The image will be on the other side. The second thing, the line OMI will be perpendicular to the mirror. So this point object will form an image on the other side where the line joining will be perpendicular and equidistant from both the sides. This is one. Second thing, whenever you keep an object in front of a mirror, there is a lateral reflection. Be careful here. Most people think, right and left get reversed. Right and left doesn't get reversed. Front and back gets reversed. Think about it. If your person, right, is standing like this, your face is looking at you, isn't it? Your front has become back and your back has become front. So front and back gets reversed. In chemistry, I don't know whether you've done organic cisterns, dekha kabhi? Optical isomers. You will learn later on. When you have these compounds like glucose and all, right? They have something called optical isomerism. Only when you're in a certain orientation, right? The human body can use it. It's called right and left. मुझे perfectly याद नहीं ऐसा कुछ. But if you just change the orientation, right? Even though it's a glucose molecule, human body can't use it. So there is something of that. You'll find mirror image molecules. Yeah, if you think in that point of view, right? Maybe, we all are living in a mirror world. Maybe we all are just images of the actual ones. Who knows? Possible. That is how humans are, right? We always think we are the center of the world. When you're going somewhere on the road, what do you think? You think everyone is looking at you. Let's say you're going on a road and let's say your pant was torn or shirt was little torn, okay? You think everyone is looking at you. You become conscious. Whereas in reality, if you think about the other way around, let's say someone is coming in front of you and their shirt was torn, completely torn, okay? Shirt was gone completely. Hand thing was gone. You will look at them and what do you think? Must have been an accident. Something must have happened. And you're gone. You're getting it. You're least bothered actually what happened. You're least bothered. Matlab, you will find a reason you're thinking, yaar, kuch to hua hoga karke, you just walk off. You're not thinking anymore. But the guy who shirt got on, he will keep thinking, "Arey yaar, this person saw me and went. What they must be thinking? What are they thinking about me?" Boss, you are not that important. No one gives a damn about you. You're getting it? You are not that important. No one gives a damn about you. Only you are conscious what everyone is thinking. Everyone has their own life. Everyone is their busy. Everyone is their own hero. They don't have, screen time for other people in their life. Did you ever see this thing when you see a road में, let's say a BMW or a Lamborghini or anything, Mercedes car going? When people see the car, what do you think they think? I'll tell you also what they think. The person inside the car who's driving it, he will think, "Arey yaar, I'm so cool. Everyone is looking at me." The guy on the road thinks, "Arey yaar, kya car hai? Wish I would drive the car." He is least bothered about the guy in the car. No one actually cares about the driver. Getting it? So don't be so conscious. In the exam, if you get less marks, no one gives a damn about it. The people who are actually studying and scoring well, they don't care about you because unka khud ka concerns hai. They just want to maintain their scores. They don't have so much time to think about you, right? So you need to be conscious. And people who are actually conscious and are poking about your marks, they have nothing else to do in life. So those people anyway are unsuccessful. They're useless. So there's no need to think about them also. So either way, it doesn't matter. Keep this in mind. I'm not telling you about this JE or something, quite a useful thing. Once you stop thinking about what others care and you just focus on yourself, you will do things in a much different perspective. You will do things that will make you happy. But if you start becoming conscious and try to do things for, to impress others, you will make your life miserable. Because no matter what you do, others will never be happy. The only person who can keep you happy is yourself. What others think about you is none of your business. and no one has the time to think about you. I'm telling you, now, whenever you feel like that, think about that. You're not that important. No one gives a damn about you. The only people who care about you are your parents and yourself. I think that's it. I really don't think anyone. If it is teachers, too, we only care about your subject. As simple as that. If you come and ask me, sir, mera max hai, I will say, yeah, I have no idea. Talk to max teacher. See, so I only care about my subject. So I think the only people who actually care about you are your parents and yourself. And you guys go and shout on your parents and all. This is what you do because they care about you. What to do? Let's see a few more problems. Let's say we have a mirror. Actually, that the optical isomerism I'm saying, na, there is a novel, okay? In the novel, na, the hero is some kind of a, I don't remember, chemist or something, I don't remember the story, but he goes into the mirror world. He goes into the mirror world, and in mirror world, what happens? Everything is in the optical isomerism types. So in that mirror world, what happens? He starts, he is happy, he's roaming everywhere, and he's looking everything. Everything looks interesting to him. He feels hungry, he goes to some shop and he starts eating it. No matter how much ever he eats, his hunger doesn't go. He always feels tired. And this guy gets shocked, yaar, kya ho raha hai mera saath? And then later on, he realizes because he went to the mirror world, even the glucose ka compound got into L isomerism, and this guy ka body structure is R isomerism. He can't use L isomerism glucose in that mirror world. So he's starving even though he's eating a lot of food. So then every time he has to eat food, he comes back to the world, eats and goes back to the mirror world. So this guy alternates between both the worlds. Once upon a time, people used to write novels like this, which had a lot of scientific stuff and creativity. Now we write all bullshit novels. Person is walking in a park, crow comes and shits on them. बस हो गया वो एक novel है. Two dogs fighting, person goes and saves. Some girl comes, novel. Bullshit novels people write. So yeah. And people get best novel prizes also for this shit. So we have a mirror at 45 degrees and we have an arrow. A, B, C, D, and D. Draw the image. Easy one. If you see, the happiest people in the world, they don't care about others. They don't care about the world. I don't mean to say that doesn't mean I shouldn't care about everyone. I don't think so. Meaning, there are some loved ones you have. It matters. So I think you should be bothered about what they think, and if they're okay with it, it shouldn't matter what others think. That's it. Your close friends and your loved ones. That you can count on fingers, 4 to 5 people maximum. So we have object here. These are 45-degree mirrors. Draw the mirror images in M1, M2, M3, M4. Yeah, it will be a downward vertical arrow. What is the name of the book? Idea nahi hai. Now, see, someone wants to read the novel. Don't study. You can read it after the JEE exam gets over. Then you'll go and tell your parents that an Arun sir only told to read the novel. ये दूसरा है. I say something, you guys use me and said. So basically this reflection, if you look at this, point A will be equidistant, point will be somewhere here, E will be somewhere here, C will be somewhere here, D will be somewhere here. You can actually see this thing. You get an inverted arrow. That is because it is 45 degrees. This will be A, this will be B, D will be the farthest, C and D. Check. The arrow will get inverted 90 degrees downward. Now using the same logic, can you find the image in these four mirrors? So you kept an object in front of a mirror and you have 45-degree mirrors, M1, M2, M3, M4. What options exam में ऐसा होगा? So they'll give four options like this. You have to mark the right one. So how will the image look like for that object, which is a vertical arrow? Try, I'll give you a minute. Left, left, right, right. I don't think so. Try others. One a minute. Straight. There are four images, right? See, for this guy, if this was the object, the head is closer, the tail is farther, this will be the image. Now, if this was so image of M1 will be the object for this guy. The head is closer, so it will be like this. Now it is like this, so tail is closer, so it will be like this. So tail is closer, it will be like this. So the images would be this, 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 and this. Check. Left, up, right, up. Swastika, you are right. Adrit, you are also right. Yeah. Some of you got it. Check what I did. So the image of M1 will be the object of M2, image of M2 will be object of M3, and so on. You just need to check, is the tail closer to the mirror or the head closer to the mirror? If the tail is closer, then it starts with the tail and rotate by 90 degrees every time. Please ask me if you're confused. Just more of a logical kind of thing. You can ask as a puzzle also.
So do they
Yeah.
make more periscope work?
पेरिस्कोप में इतना नहीं करते रे. They use only till here.
Okay.
इतना ही है ना. इतना क्यों करने? मतलब the whole point of periscope is you are in a ditch or something, you want to see outside, na? If you make like this, again you're at the same level. That guy will just shoot you through this thing. It's a bad periscope.
Okay.
I just made it more. It's a double. Actually, it's an half. You should take half of it. It'll be a periscope. Next one. We have a mirror here, 60 degrees. We have an object here going with V. Find the velocity of the image. This is V minus I cap. Vector form I want in terms of I cap, J cap. The object moves horizontally towards the mirror. Find the velocity of the image. Now this is 60 degrees, not 45. So you can't say it is down. Get it? Try. You got 2 minutes. This is basically a vectors question. Minus v by 2 I cap v root 3 by 2 j cap. आइडिया नहीं है यार, देखना पड़ेगा. Let's see. What is the idea here? So when this is the velocity v, you can divide this into two components. This would be 60 degrees. This would be 30 degrees. So this component will be v cos 30. And this component will be v cos 60. So whenever this thing hits, the component along the mirror will get reversed. So this guy will become v cos 30. Whereas the component parallel to the mirror will remain same. This will be v cos 60. You're getting it? So the parallel component remains same. So this guy remains same. This will get inverted. So basically you got two components here. V cos 30, V cos 60. This is 60, so this is 60 and this is 30, 90. Now take the component. So velocity of the image will be v cos 30 ka cos 30 minus v cos 60 ka cos 60 I cap minus v cos 30 sin 30 plus v cos 60 sin 60 j cap. That would be cos square 30, so 3 by 4, half 1 by 4, v by 2 I cap minus cos 30 sin 30, so root 3 by 4 root 3 by 2, v root 3 by 2 j cap. Check. Adrit, you messed up the eye component. Aryan, you're wrong. Niranjan, you are right. Aditya, first part you goofed up. Kya? Yeah. Check where it went wrong. So the main idea is that you take the divide into two components, one parallel to the mirror, one perpendicular to the mirror. The parallel will remain same, the perpendicular just reverse it and again resolve and finish it off. Like I said, more of a vectors problem. Vector resolution.
So the magnitude of the velocity of the image
Will be
will
same.
be the same as the object, no matter the orientation of the mirror, right?
Yeah. Yep.
So we could have assumed the mirror to be straight
Okay. Assume. So this will go like this.
and like tilted the actually, yeah.
Okay, then what?
What happens, sir?
Then what will happen? Then you still have to do the same thing, no? You still have to resolve.
Exactly. That's what I said. Yeah, the same thing.
Same thing. It really doesn't matter.
Ah,
Clear, everyone? Next one. Turn in the page. Any doubts on this? We have a mirror which is going with velocity v at an angle alpha. Here you projected a particle with u and theta, projectile motion. Find the velocity of the image as function of time t. Mirror is also moving. Object is also moving. Find the velocity of the image at time t with respect to ground. Let's get this. How do we do this? Mirror is mirror is going in a constant speed. Mirror पे projectile नहीं है. You know what? Mirror is going with constant speed. Mirror is simply sliding like this. Mirror is just going like this. Try. 2 minutes. It's a good one. First thing, if you look at this mirror, this mirror ka velocity can be divided into two parts, v cos alpha and v sin alpha. This does not affect the motion of the problem particle. That's the first thing you need to figure out. Think about it. If there's a mirror in front of you, listen, mirror in front of you and you're standing here. If the mirror comes towards you, won't the image also come towards you? But what if the mirror goes this way? Will the image go away? That will be quite scary. Think about it. You're standing there and the mirror goes like this and your image goes off with the mirror. That's a ghost. That's not an image. So no matter how much the mirror goes left and right, your image will be there only in front of you. Is that clear, everyone? So the mirror ka v sin alpha is useless. That's the first part in the problem. This is going with u and theta. Abhi kya karna hai? Try. I'll give you another minute. The mirror ka component is useless. That this is as good as a mirror coming towards only the v cos alpha you have to take.
So how's the object moving?
Projectile.
Okay.
Gravity to diya na projectile. Mirror is going in a line, but object is going. It's just falling down. To find as function of time t. So what we do here, stop the mirror. So at any time, if you look at the velocity, this guy will be u cos theta. This guy will be u sin theta minus gt. Whenever mirror is moving now, not only this thing, later on we will study, okay, even if you have curved mirrors, always stop the mirror. Keep the observer on the mirror with respect to mirror. Then with respect to mirror, you think this velocity also will be v cos alpha. So with respect to mirror, it feels as if this guy is going with u cos theta plus v cos alpha. Agreed? So how will the image go then? The image also will go this way with u cos theta plus v cos alpha, and the vertical component will be u sin theta minus gt. So velocity of the image with respect to the mirror is minus u cos theta v cos alpha I cap plus u sin theta minus gt j cap. But you want velocity of the image with respect to the ground. That is nothing but velocity of the image with respect to the mirror plus velocity of the mirror with respect to the ground, only the horizontal components. You don't take the vertical. So ignore this. So your final answer would be, what is the velocity of the mirror? Minus v cos alpha I cap. I'll do one thing. I'll just add up. Well, this is fine, I guess. You understood, I suppose. That would be minus plus v cos alpha I cap. The horizontal component will be 2v cos alpha. Check. That's your answer. So stop the mirror. Then it becomes easy to see. Find the image, and then image जो भी आया, just add mirror का velocity. You'll get in the ground frame. Always, whenever you're solving with respect to, this is not a concept, but a kind of a technique. After comes with experience when you see. So when we try to find the velocity of the image, always stop the mirror. When we try to find the velocity of the image, always solve with respect to mirror and then come back to ground frame. Check. Clear? Next one. Any doubts on this? Projectile, vectors, optics. 3 chapters. Next one is fun. We have a person who is 2h. We have another person here who is only height h. And in front of them, there is a mirror. This is h. This is also h. So let's call this A and let's call this B. So we have two people here, A and B. A ka height is 2h and B ka height is 2h, and this guy is a mirror. Find the minimum length of the mirror so that B can see himself and A completely. So this person B, when he looks into the mirror, you can neglect that, that he's blocking the view. Forget about that, right? You can find the minimum length of the mirror so that B can see himself and B should also see A also behind him. And you can assume the eyes are, neglect the distance between the eyes and the head. You can assume the eyes are on top of the head. Neglect distance between eyes and the head. So you can just assume eyes are on top of the head. It really won't matter, but makes your life a little easy, nothing much. Is my question clear? You're standing and behind there is a taller person 2h and there's a mirror in front of you. You are supposed to see yourself. You're supposed to see that guy also completely. Head to tail, everything. Head to legs, head to toes. You don't have a tail. Yeah. Get this. How do we do this? This would be an advanced question. Advanced ka, yeah, easy to moderate. I'm sure you must have done this question. Find the minimum height required to see yourself. That though is a standard answer. Think I'll give 3-4 minutes. Any answers? Think. It's a good one. Anyone not clear with the question, please ask me. Venkatesh, Rehan, Vidyut, clear so far? Vidyut, you're there? Yeah. Overhead नेरे 2 wickets. Minimum length पूछा मैंने. Overhead is just too big. Okay. Let me see what you did. It's an interesting one. You guys remember this thing? We did this something like this in foundation, I guess. Nee, Yasha, that is wrong. Rehan, wrong. Abhinav got it right, though. Ranjan, wrong. Ali, wrong. How did you get H by 3, Abhinav? To see the other guy, how did you say H by 3, H by 3? What is the logic there?
You are referred to the foundation wala summary.
I thought you must have forgotten. You remembered it. Number change करना चाहिए था ना? But do it, na? Do it on your own. Because exam they won't ask you the same question. And we did the foundation. Listen. First thing, if you look at B, we are assuming eyes are on top of this thing. So we need a mirror such that these light rays will go here and come back. The light rays here will hit and go here. So to see yourself, and this is exactly equal. So if this total height was h, this is h by 2. So to see himself, you need a mirror of length h by 2 starting from the eye level. This is important. To see himself, we need a mirror. Length h by 2 starting from eye level. Now for A, when I say you're actually looking at A, what are you looking at A exactly? You're looking at the image, right? You are actually looking at the image of A. Mirror is somewhere here. This is the image of A. So B is actually looking at the image of A. Now, if you look at this triangle here, and this is how much? 2h. So this also will be 2h. You can see from the similar triangles there, this is height 2h, this is 3h. At a distance h, this height will be 2h by 3. Make sense? This was the mirror. That means to see A, the mirror should look like this. A length 2h by 3, starting from the center. So you need a mirror h by 3 on the top, you need a mirror h by 3 at the bottom. Please have a look at this. To see yourself, you need a mirror starting from your eye level, but to see the other guy, you need a mirror starting from the h by 3 above your eye level, h by 3 below your eye level. Now, if you combine both of them, now most people, what they do, they think answer is 2h by 3 because that looks the minimum. No. To see A and B, we have to satisfy two conditions. You need to have a mirror h by 2 below your level, h by 3 above your eye level. That will satisfy both the conditions. So the answer is 5h by 6. Please check. If it is h by 2 below your eye level, that will cover h by 3 also. The problem with seeing yourself, there's no mirror on top of your eye level. And without a mirror on the above your eye level, you can't see A properly. So you have to take a common of both the mirrors. So the mirror ka orientation starts mattering here. Have a look at this. Ask me if you're confused. Anyone not convinced with this? Not clear? Please ask. Clear? It's by 3 part. See now. This is the mirror, right? Aryan. So in order to see yourself, can you see this is the mirror, isn't it?
Yes.
And uska length kitna tha? 2h by 3 total. That you got it.
Yeah.
But that means h by 3 above your eye level, h by 3 below your eye level. So below the eye level kitna chahiye? H by 2. So that you can see yourself. Above eye level kitna chahiye? H by 3 to see A. So you need to have both of them, na?
Sir, h by 2 क्यों?
First case.
Okay.
We are combining both the cases, seeing himself and seeing the other one. Clear with this, everyone? Any doubts on this? Great. Next thing. So if you have two mirrors, how many images can you get? Number of images for two inclined surfaces. So let's say we have a mirror. And if you take an object here, and if this is angle theta, you will find the image will be somewhere here, and that also makes an angle theta. So basically, whenever you have an inclined mirror, the image and the object, right, they will make the mirror will be an angle bisector. So image will be always So whenever you keep a mirror, the image will be plus theta from the mirror. Image will be at an angle theta on the other side of the mirror. So these are some of the observations. The second thing, all images will lie on a circle. All images that form will lie on a circle where radius of the circle is distance between the object and the point of intersection of the mirror. Let me show an example. Meaning, if you take two mirrors like this, let's say if you keep an object like this, and if you draw a circle, you will observe the images will be again this I1, I2, I3, I4. So you'll get all images on this thing like a circle. So case one, the number of images will be n will be 360 by theta minus 1 if 360 by theta is even. Independent of position of object. I'll give you examples on that. So just to take an example, if we take a simple case, 90 degrees. If we take an object here, this will give you an image I1, this will give me I2, and I1, I2 will create again images on this thing, which will be I3. So there'll be like 3 images. Case 2, n will be 360 by theta. Let me write in the next page. Have a look at this. So if you take two mirrors at a 90 degrees, right, and you put an object on the bisector, you will see 3 images. And this is what actually happens here. See, this is the object. So these light rays from here will go to this mirror, na? So M2 will think I1 is also an object. So these light rays are coming, M2 will think these light rays are coming from I1. So M2 thinks M1, I1 is also an object. That's why you get and creates I3. So the light rays, after hitting M1, some of them will bounce on M2, and that will give you an illusion that's an image. Check it out. Case 2. If 360 by theta is odd, n will be 360 by theta minus 1 if object is on the bisector. Because if the object is on the bisector, the image will overlap with the one of the image will overlap with the object. Number of images will be 360 by theta, but let me give you a better way of figuring it out. I'll show you how to get that angles also. If object is not on bisector, but be careful, this is valid only if 360 by theta is integer. You get 7.3, 7.4, it doesn't make sense. You take the nearest integer. There are some standard formulas, but let me show you a better way, which might be a little more lengthy, but that will be more information. But have a look at this. Clear? Now, let me take an example how to figure it out. See, listen to this carefully. Let's say we have two mirrors. M1, M2. Let's say you kept an object somewhere here. Let this angle be alpha, let this angle be beta. It is not on the bisector. So what we do here, add theta. So that's what we have seen. Every time you put an image, you get an angle theta from that mirror there. Add theta to get an image in the next mirror. So this is what we do. Image formed by M1. Image formed by M2. So you start with alpha, beta. Then you add angle theta. So you will get an image in the second mirror at an angle of alpha plus theta. Again, you add an angle theta. So then you get an image with alpha plus 2 theta. Now the image will form an M1. Similarly, this guy, you are adding theta is the, wait, what is theta here? Theta is angle between image M1 and M2. There's alpha plus beta basically. So then this guy will become beta plus theta. That means the first image formed by O in M2 will be at an angle of beta plus theta. Then again, this would be again beta plus 2 theta. You keep doing this, right? You keep on doing this till you get an alpha final, beta final. So we need to do this till you reach 180 degrees. I'll show you with numbers. But this is the process. till you reach 180 degrees. Once you exceed 180, stop. Up to 180. Now, while doing this process, if your alpha final plus beta final and that angle theta, if this guy becomes 360, that means the last two images will coincide. The two images formed by that M1 and M2 coincide. Just have a look at this. Let me take some numbers and explain you. That I think you'll understand better. Let me show an example. We'll get back again here. See, we have a mirror. M1, M2. We have an object here. This guy is 30 and this guy is 60, not on the bisector. And theta is 90, angle between them. So I want to find the position of the images. So M1, M2. So first thing, M1 ka angle is how much? M1 to object ka angle is 60 degree. So start with 60. M2 ka angle is how much? 30. Then what you do? Add 90 to this. So 90 plus 60 is 150. So this guy will form an image at 150 degrees. Okay? Somewhere here you get an image I1. This angle is 150 degrees. Are you getting it? So that is an angle in M2 at 150. The meaning of this is, with respect to M2, the image is at a 90 degrees. So it is like this. M2, this angle is 150 degrees. And for this add 90, this will be 120 degrees. If you try to add 90, this will exceed 180. So done, question is over here. So that's your final answer there. You can't go more than this. If we add more, we cross 180. If we add more, we cross 180. So, and the last two things will be 120 plus 150 plus 90. This is 360. That means the final images coincide. So this is how the diagram would look. M1, M2. This was your object. We get I1 here. We get I2 here. They will form an image here, I3 here. That will coincide. $60, $60. This was 30. So see, if you add all these things, you get 150. If you add all this thing, you'll get 60 plus 30 plus 30, 120. I hope you're able to see that angles. This all angle is 120. This all angle is 150. That's what you're getting. There.
So if the angle between the two mirrors is 120, only two images will be formed.
No, basically see na, ये first image है ना?
Huh?
See. From this mirror, we got an angle at 60.
Yeah.
For mirror, actually, ऐसा भी सोचो. This is 30,
Yeah.
and the other one is like you can measure like this also. Actually, you can go like this to 120, or you can go like 150, or you can go like this 120.
No, so I was asking you if the angle between the two mirrors is 120.
The angle between two mirrors is 120. Okay.
So then that I1 here won't be formed, right? Only that I3 and I2 will be formed
No,
because
180 भी चलेगा. You can get up to 180. No, that won't. Then right. What you're saying is like
because the
angles
mirror's
cannot exceed.
position will be at I1's position, right?
तो वो नहीं लेंगे. Then what you're saying is true. Then you get only how many images? 2 images.
Hard to thank you.
You're getting it? So the first image will form at 60. I think, let me explain it that I can see, listen. So the first image will form at 60 from M1. So that is this guy. Second image will form 30 from M2. That is this guy. And the third image will form from 120 from M1. So that is this guy. The third image for M2 will form 150 from this guy. Luckily, that is the same point. So they will overlap here. You're getting how to measure that? So if I take circle, I think you'll understand better. See. M1, M2. Look at this thing. The first image, 60 degrees from M1. The second image, 30 degrees from M2. मतलब ये meaning था. You can count like this. The third image is 120 degrees from M1. And this is 150 from M2. That is also I3. They're overlapping. Are you getting the images? I didn't draw the perfect circle, but uska meaning wo tha. 30 degrees from M2, 150 degrees from M2, you get two images. 60 degrees from M1 and 120 degrees from M1, you get two images, and 120, 150 overlap if the total angle becomes 360. Sure. Let me take one more example. We will do more on this thing next class also. Let's say M2. This is the object. Let's say this is 10 degrees and this is 50 degrees. Listen carefully again, I'll tell you. M1, M2. So the first image will form for M1 10 degrees from the other side. So this is your first image. Means that will be 10 degrees on this side, ESA. For M2, the first image will form 50 degrees on the other side. This is the first image on M2. You can say second image. So this plus 60 will give me 70. 70 plus 60 will give me 130. 130 plus 60 will give me 70, 10 plus 70, 70 to 130, 132. It will exceed 180, so we don't count. For this guy, 50 will give me 110. 110 will give me 170, and then we don't count, so done. So we have total 1, 2, 3, 4, 5, 6 images. And the last thing, 130 plus 170 plus 60 is actually 360. And that means last two images coincide. So the number of images is 5. So you want to look at the images. Now see, listen carefully. This is what I was saying. This is the circle. This is M1. I'll just show for M1, okay? So if the first image of M1 is at 10 degrees, the second image is at 110 degrees. The third image is 130 degrees. And 10th, that will be close to 90 only, no? 10, 70, sorry. The red ones are the M1 ka things. And the third one is 130. Now for the M2 guy, the first image is 50 degrees. Then the next one is 110 degrees. The last one is 170. That comes out here only again, I6. So they overlap. Make sense? So have a look at this. Don't worry too much about this. After the major test gets over, again, we're going to do, I'll revise this stuff once more. We can do more examples. So this will be useful to find the exact number of angles. But if you just, the question is find the number of images, we can just use these formulas and get the answers. And 360 by theta minus 1 and all. But if you want the position of the images, then this will be useful. Clear? So that is one. So next week, right, what I was thinking, like, you know, there's no point in teaching. You guys are already busy preparing for the major test. So we'll not have a class on Wednesday and Friday. Next week, we'll just have only doubt solving sessions. So I sent you the sheets. You already have enough work to do. Start solving them, right? Whatever doubts you have, you send me in WhatsApp. I'll give you a time slot. You can come during your time slot and get your doubts cleared. But maximum try to send it before Thursday night, 10 p.m. If you send me on Friday, it's difficult to give a slot. Whoever comes first, you'll get a slot first. Same thing we did last major test, if you remember. We will keep it simple. So whatever doubts you have, you send it in one go. Don't do like this. Tuesday, you will send 3. Wednesday, you will send 2. Thursday, you will send 1. I'm not going to give you 3 slots. Send all your doubts together in one go. Finish off physics ka preparation by Thursday. Friday, you can sit and prepare for chemistry. So plan like that. And physics ka to hai clear. So next Wednesday, Friday, we'll not be having classes. It's only doubt solving. So if you send me all your doubts on Tuesday, I'll give you a slot on Wednesday. If you send it on Wednesday, you'll get it on Thursday. Thursday, I'll give it on Friday. If you send it on Friday, Saturday is your exam. So do send it before Thursday.
Sir,
हाँ,
we
हाँ.
had left instruments during UNT.
But instruments hai kya? Portion mein hai kya? Wernicke calipers, screw gauge, they're asking.
Yeah,
Did they teach?
yeah.
Yes,
ठीक
sir.
है ना? Then चलेगा. Then Wednesday I'll teach you instruments. Maybe it'll take an hour or something. Then I can take doubts. So we'll catch up on Wednesday for instruments. Big deal. But I don't think they teach you. But ठीक है, I'll teach you big deal. कुछ नहीं है. Wernicke calipers, screw gauge, no?
Yes, sir.
Yes, sir.
चलो कर लेते then. Not a problem. So Wednesday we are meeting as usual. Then maybe we'll start at 6:30. Maybe it will take an hour. We'll finish off the instruments. So whatever doubts you have, you can send. I'll give you a time slot. Chalo. Then any doubts, anything, stay back and ask. I'll be free to leave. So take care, stay safe. I'll see you again next Wednesday at 6:30.
Bye, sir. Thank you, sir.
Bye, Ray. Take care.